Okay. Until now, we are all talking about linear analysis for single degree freedom. So this time, we're going to talk about nonlinear analysis and how to calculate structural response by that. And until last time, we learned Newmark beta method and incremental method and restoring force-based method. As Newmark beta method only uses k as a constant, so we cannot update k for every step. Thus, you can get for storing force k by wrong way. So Newmark beta method can only calculate linear case, but cannot calculate nonlinear case. To calculate some structure nonlinear problem, we need to use incremental method or using restoring force method directly. Later in the next time, we will also introduce more accurate and more easier to coding method called predictor and corrector method. Let's take a quick look about bilinear model. Different with linear case, the displacement and force relationship initially, though, they are according to a fixed stiffness K1. However, if the displacement is larger than d1, dy, or Fy, force larger than Fy, they will yield like this. So their stiffness will change to K2. However, once they are unloading from the plastic domain, they will come back to the elastic domain. After come back to the elastic domain, how to setting the elastic range or setting again the yielding force have multiple rules, Harding rules. So here we just using that rules that we consider the domain of elastic will switch as much as they load into elastic domain. So they will finally the result will be look like this. So you can realize that under earthquake response, the hysteresis curves is for the displacement and force relationship will like this kind of loops. They're loading, unloading, yielding, unloading, yielding, unloading, something like this. So how to calculate this model? We need at least 3 parameters for bilinear model. They can be dy, Fy, alpha. And there will be 2 status for bilinear model: elastic status and plastic status. And from elastic to plastic status, there is event called yielding, and when the unloading event happened, the model will come back to elastic status from plastic status. And the parameter we explained, dy is yield displacement, Fy will be the yield force, just like this. For elastic domain, their stiffness we call the first stiffness K1, just the same with the K, and which is the ratio of Fy divided to dy, because until here they are following the elastic rule. However, for the plastic domain, they have the this plastic stiffness, which also called second stiffness, which generally is smaller than K1, using a ratio alpha from 0 to 1 to express K2. So alpha will be the K2 divided to K1 ratio, or we say second stiffness ratio. Initially, before any loading happens, structure will be in the elastic status, and the positive and negative, the displacement should be 0, and the yielding or say elastic domain limit dy1, dy2 will be dy and minus dy, like this. However, once displacement in n plus 1 step, it will be over dy or under dy2, the stiffness will change to plastic over that, something like this. And on the contrary, when the loading in the plastic domain, once the loading direction changes from positive to negative, or from negative to positive, then they will go back to the elastic domain using K1 like this. But at this case, their yielding or say elastic domain will also limit dy1, dy2 also be changed from here. How to change the elastic domain? Initially, we have dy1 at dy, dy2 at minus dy. After loading to here, we can see that the dy1 will be changed to dm, which is the unloading displacement, and dy2 will be 2 times of dy until this dm. So it should be negative direction, so it should be dy2. Or when we load into the negative direction and they go back to the positive direction, so the lower dy2 will becomes dn, and dy1 will becomes dy2 plus 2 times of dy. Thus, is a bilinear model summary can be summarized like this. They change from elastic to positive direction, and 2 events and changing status and update elastic domain is necessary. This is a figure that summary all the things that you need to know. And the yielding, the status is elastic domain, and under this condition they will yielding. And when the plastic domain, when this happens, they will becomes elastic domain. So we explain that go to positive direction, go minus. So Vn positive, Vn plus 1 is negative. In that case, they multiply together smaller than 0. Same way, when the Vn is negative and Vn plus 1 is positive, multiply together, still they were smaller than 0. So how to analyze this kind of procedure? It will be very easy. The first step is just to change the Newmark beta method to incremental method to calculate the response. And next, you can calculate the force of n plus 1 step by this last time's force plus the incremental of nonlinear force or linear force by k changing from k1 to k2, and with the n plus 1 steps displacement incremental. However, different is every step you need to update k due to some conditions of bilinear model. So you need an equation to calculate the k for next step. In this, because k is changing step by step, so m hard, a, av, r becomes variables changing with the k. So every step you'd better updating these parameters too. So this is all the contents about nonlinear model you need to know. So you can try to make a program to calculate nonlinear simulation.